Good morning, everyone. We're going to get started here in about a minute. Give another bit of time for other people to join. We're happy to have you here again. Okay, Jamie, I'm going to get started. All right. Good morning again, everyone. Let's get started. We want to welcome you to the third installment of our ESD Clinic. A little bit of a change this morning. We're really excited to have a guest trainer, Jim McKeon, who you can see right now on the screen. Jim has been with Desco for 33 years in various capacities, including National Sales Manager. Currently, he heads up their customer training program. And as you can tell, not only we have Jim, but he's back in Canton, Mass. So they're back at their facility there where he's going to do the training. We're also going to jump to topic 4 today on ionization. Greg will finish up next week and get back to the continuous monitors. This is Tom Cerati with SMT Supplies. We're the sponsor for this free Desco ESD Clinic. Just a couple reminders, as I've done the past couple weeks, you will remain muted for the duration of the training, but at any time, please type in any questions into the Q&A feature. If there are enough questions midway through, we might pause to answer, but we'll certainly get to all of them at the very end of the session. And again, the session will last for 30 minutes of training, and then we'll have 15 minutes of Q&A. Jim, it's all yours.
Thank you, Tom. Thanks for the introduction. So I'm sure that you're probably sitting there saying, how does Desco get all these young sales guys to work for them? And I guess they're just lucky. Greg's up at the ESD Symposium, which is why I'm taking over today. And hopefully you'll get something out of this presentation. So there are 3 topics we'll be covering: ionization, process essential insulators, and isolated conductors. And as always, when I train, I'll I'd like to assume that there's not a lot of knowledge there, and I apologize in advance if I tell you something that you already know, but it's best to start go with the basics. So ionizers are a product that really need to be understood for them to be used effectively. Overhead ionizers, for example, are $1,000. So it's important that you understand what they're used for, how they're used, how they're tested, to make sure that you're getting the most benefit from your ionization. The purpose of an ionizer is to remove charges from an insulator that might be near some ESD sensitive devices. And the problem with insulators that are near ESD sensitive devices is that the charge from the insulator can be induced onto the device, which leaves the device charged. And a device that has a charge on it really isn't a problem. What's important is what is the next material that charged device touches. If it touches a typical work surface, nothing bad is going to happen to that device, because the resistance of the work surface is going to be in the right resistance range to take the charge off the device quickly, but not too quickly. If the next thing the charged device touches is conductive, and we'll be talking about some of those things a little bit later, the device will discharge too fast and it will cause a charged device model event. There are 2 general types of ESD events: human body model, which is a person ungrounded, not wearing a wrist strap, foot grounders, etc., touching a device and putting a charge into it and damaging it. Charged device model is when the device is charged and it touches something that's very conductive. And it's a known fact that charge device model events, ESD events, are more destructive than human body model events. Human body model events happen in nanoseconds, and I've seen graphs of it happening where it goes across and then down. And a charge device model event happens in picoseconds, so it's faster and it's more severe. And I've seen charts where the graph goes straight down and straight up. So the other thing about insulators and charge device model events is they're more difficult to identify. You can walk around your facility and see who's wearing their foot straps or their wrist straps and pretty easily determine whether you're covered there or not. But insulators are all over the place in many facilities, so it's important to identify them and to know what to do with them and how to handle them when you do find them. So I'm going to go to my PowerPoint now. I'm going to move this down for a second. That should be good. Bear with me for a second, please. Okay, so as I mentioned, we're going to be talking about process essential insulators, isolated conductors, and ionization. And with the previous presentations that we've had, we'll go through the PowerPoint, and then I'll do some demos for you afterwards. And as Tom mentioned, if you have any questions, type them in. Matt will give me the high sign if a question pops up, and then we'll take care of it. Ask your questions and we'll break for answers. So again, we're talking about process required insulators and isolated conductors, some of the requirements for ionization and types of ionizers. And when we do the demos at the end, we'll do some demos of how to test, discussions of offset voltage, and how fast. We'll discuss the important topic of how fast an ionizer has to work. So process essential required insulators are insulators that are going to come in close proximity to your static sensitive devices. The rules for distance rules for insulators near devices is if the insulator has 125 volts to 1,999 volts, then that insulator needs to be at least an inch away from the device. If the insulator has 2,000 volts plus, it has to be a foot away. And of course, if you can't do the distance situation, which is often the case in process required insulators, then you need to think about ionization. So some examples here are the printed circuit board itself is an insulator. Plastic connector bodies and cap plugs that are commonly used are generally not ESD non-generators. Cabling, product enclosures, plastic cases like this is, I think, a Desco surface meter that is pictured there. So the plastic enclosure is going right on top of the board, and using ionization is important in that case to take the charge off the plastic enclosure. And tool handles. So if you have a tool, whether it's a hand tool or not, if it's an insulative hand tool, then you're going to be risking getting that insulator material near the board. Non-process essential insulators. I'll do a demo on that later, but you know, we see people have water, pocketbooks, and you name it on workbenches. And with the new 2021 version of S20.20, in that version, the requirement is for non-process required insulators to always be a foot away from devices, whether or not they have less than 2,000 volts or not. Isolated conductors. Generally speaking, I would say that companies don't pay a lot of attention to isolated conductors, but it's a topic that is becoming more to the forefront of good ESD control. So if you have an isolated conductor, that conductor can charge up, and then if it touches another conductor, it will discharge. So proper grounding takes care of a lot of it, but if that's not possible, then you need to consider ionization. So some examples are ESD sensitive devices sitting upside down on the work surface where the leads are exposed and not grounded. People not wearing grounding devices while they're handling devices. And if you had a pile of ESD sensitive devices in non-protective and ESD protective parts bins, then the non-protective parts bins would charge them up. Some other examples are in-circuit testers, device level microprobes, cables that can be connected for testing purposes. So especially for those last three types of cabling, testing types of products, really there are two choices. The item needs to be grounded to less than 1 × 10⁹, or using a contact or non-contact voltmeter, you need to measure the charge on those conductors. And the upper limit of acceptability is 35 volts, positive or negative. So it's important to identify your isolated conductors and deal with them properly, whether it's grounding them or using ionization as appropriate. This is from S20.20 2021, and it's the product qualification and compliance verification information on ionizers. So product qualification is basically, as a user of ESD products, you should be qualifying them before you use them. And that can be done either by sending them out to a lab, independent lab. If you have a lab in-house, that's fine too. Or if you buy a product from a company, they should have listed the testing that was done on that item, and you can use that. So a key thing on this page is the required limits. Discharge time is user defined. So there are there's an infinite number of setups for ionizers and products, different distances, different environmental aspects, but different speeds that are required. So we're going to talk in a little bit about defining the discharge time that you should have with your ionizers. Offset voltage is another important topic. So when the ionizers blow out positive and negative ions, if the ionizer is blowing out an excess number of either one, positive ions or negative ions, then that any ungrounded devices in the airflow of that ionizer can be charged to that polarity which had the excess. And it's also often called balance, being in and out of balance. The official word is offset voltage. So we're looking at a maximum of 35 volts, positive or negative. And again, a contact voltmeter would be what you would use to actually measure the charge on a device. And we're going to talk about testing for offset voltage when we do the demos later. When I was active in the field, Tom didn't mention, but I'm kind of semi-retired. I work a few days a week doing these training things, but when I was in the field, I would sometimes ask the customer, what a what an ionizer does and can it do this, just to get a feel for where they were at. And you know, more often than not, there wasn't a complete knowledge base there. So, you know, ionizers are not a replacement for grounding. It's just one component of a static control program. And ionizers are used both in companies that are handling static sensitive devices and also in companies that use it for particulate control in clean rooms, sort of two separate applications. And we'll talk a little bit about each of those a little bit later. So, and that's, again, as we saw before, the discharge time is user defined. So you have to decide how fast the ionizer has to work to do its job. And we're going to talk about that a lot more in the demos. I don't think I was going to say more about that. Types of ionizers, blow-off guns. So we're going to be mentioning two technologies of ionization: AC, which is alternating current, and DC, which is each emitter pin in the ionizer has either positive or negative ions produced from it. But most blow-off guns are AC. So each emitter pin has produces both positive and negative ions, and it's used generally to dislodge charged dust and debris off of boards, off of, you know, anything. And that's to eliminate further attraction of dust and debris, visual imperfections on whatever the product is, and any general contamination. One thing worth noting is that if you have a regular air gun and the air going through that gun is clean, that air won't generate a charge on anything. And the reason for that is the air molecules are so small that when they have a contact and separation with the surface, they don't create enough static. So the question is, why would you even want a gun? Well, sometimes there's debris on surfaces that is there because it's charged and it's attracted to that material, and just the air itself won't remove that debris. You need to both have the air power and the ionization benefit to loosen it, I guess we'll say, off the material. But most companies that are working with static sensitive devices and blowing guns on them do use AC. But just for the sake of the conversation, you know, a regular air gun will not generate a charge if the air is clean. Ionizers with fans, and these are the most common types of ionizers in the business that mostly Desco serves, which is, you know, general manufacturing with static sensitive devices. Steady state DC means that each emitter point inside the ionizer has either a positive or a negative charge versus, produces either positive or negative ions, which is different than the AC, which I said produces both positive and negative on each emitter point. And one of the things about AC ionization is that the ions are being produced at 60 hertz, which is every 60th of a second. And positive ions are heavier than negative ions. So you have this wave of ions being produced every 60th of a second. And because the positive ions are heavier, the negative ions are moving faster and they catch up to them and they neutralize each other. And so what that results in is oftentimes the need to make the fan of an AC ionizer blow faster to keep the positives and negatives separated. But that can cause problems with solderability on devices. So just something to be aware of. The auto feedback system in the Desco, at least the Desco steady state DC ionizers like the ones I'll show you. So we have a question, hold on. How am I doing for too long? Okay, I'm being warned that I might be going a little long. Okay, so DC ionizers have the ability to alarm if there's a catastrophic event. And the catastrophic event, in that case, the way it's measured is if the input voltage into the ionizer, obviously it uses 110 volts. If it drops to 85, which would produce much fewer ions, the ionizer will alarm. So that's what that auto feedback system is about, an audio and visual alarm. And the last type, ion bars are generally used in laminar flow hoods where there's very little airflow and they produce positive and negative ions, and the air within the laminar flow hood brings the ions down to the material that is trying to be ionized and neutralizes it. Room ionization is really used for particulate control. You'll see the picture there. Those are emitter points where the ions come from. They're generally not air assisted. And so it takes probably 17 seconds for I think it's an average time for those ions to reach the table level, or sometimes it's more. And these room systems are generally used just to keep the charges off of insulators so that any debris in the air is not attracted to any materials. It just kind of stays free and goes down to the collection area of the room. So room ionization systems are really not for protecting devices, they're for preventing electrostatic attraction. So this is a quick recap. Ionization is necessary when handling process required insulators or isolated conductors. We want to talk about the 35 volt offset voltage and user-defined decay rate. And I always recommend, in general, for people to have an expert like Greg come in if you're really unsure about any of your ESD program, but particularly when it comes to ionizers, to make sure that for that expensive item, you are going to make the right purchase. Okay, so I'm going to put the camera back on. Okay, Tom, how am I doing? 5 or 10 more minutes?
Yeah, that should work, Jim.
Okay, so let's talk about how they work. An ionizer, this ionizer, for example, takes the 110 line volts. There's a step-up transformer inside, steps it up to 3,000 to 5,000 volts. The high voltage goes to these emitter pins that are in here. The camera's not good enough for you to see them. And the ions are created, and then the fan blows them out. That's basically how they work. Let's talk about the user-defined aspect of ionizers. So the ionizer, the problem it prevents is from an insulator. Here's a plastic paddle being too near this board. Charge goes onto the board, and then if I touch it with a hand tool or something metal, it's going to discharge, and that's a charge device model event. So I'm going to use an example of headlights. So in the Midwest, we do a lot of business with companies that make headlights and tail lights, and they have electronics in them. So let's use that for an example. Here's the headlight, and this board is going to be going into it, and it's on a conveyor belt. So what has to happen is the ionizer has to take the charge off of the headlight before the board goes into it, and then people start attaching it, okay? So let's say it's a fast moving conveyor belt, and every 8 seconds, a headlight comes in front of a person, they take the board, and they put it in. That ionizer has to take the charge off of that headlight in 8 seconds or less. If it's a slower moving conveyor belt and the headlight comes in front of a person every 25 seconds before they put the boards in, then the ionizer has to work in 25 seconds. So you need to look at your applications and determine how fast an ionizer should be working for you. So the general way that ionizers get tested, and you're not going to be able to see the actual dial of this very well, but I've got this field meter and a charging plate. And the way that you test how fast an ionizer is working is how long it takes to decay 1,000 volts to 100. So let's see, I'm not sure if you can see that. Okay, so I'm going to put a charge on there. It's almost 1,000. So I'm going to take this and I'm going to put it at the spot where the insulator sits. It doesn't do any good to put it up here. You want to know how fast it works here. So I'm looking for either 8 seconds or 25 seconds based on what it was that we just, based on the time it actually takes required before this device goes into the insulator. So there's a, so that's 1,400. So when you have it on the ionizer, you start counting down when it gets to 1,000. And then when it gets to 100, you stop counting, and that's actually your time. So you can see it's very slow because it's not in the air ionizer. So I'm going to put it over here under the air ionizer, and you can see the charge is gone. Okay, so how do you test for offset voltage? Well, you can either just hold the instrument underneath the ionizer and see if the ionizer puts any charge on it. In this case, it doesn't. It's all zeros. Or you can, put the 1,000 volts on it, kill 2 birds with 1 stone, and then put it underneath. And that took about 3 seconds. And now it's at 0. If this ionizer was out of balance, it would show some number, 10, 20, 30, whatever it would be. So you can do the decay test and do the offset voltage test at the same time. And again, we're looking for 35 volts. Another important thing about using ionizers is to be careful to make sure that the airflow of the ionizer gets to the spot where the work is being done. Excuse me for 1 second. Okay, so if this is the target area right here, and let's say it's 6 seconds. I'm gonna put the charge on there, 2, 3, it took like 2 seconds. So if you're looking for 6 and it takes 2, that means the ionizer is working well. But sometimes we see situations where there's a lot of things on the bench and people think, well, you know, the ionizer is gonna work no matter what. So you have something on the bench blocking the airflow. I'm gonna charge it up. I'm gonna hold it here. It's 500, 300, 200, 100. So that took about 8 seconds. So there's a substantial difference between not having a blockage and having a blockage. The other thing is that sometimes companies use benchtop ionizers to cover the whole bench, which is fine. But if you're thinking that it's going to work, can you see where I'm pointing? Yeah, down at the far end, you need to find that out, because if you're working on devices down there, so I got it there. It's going very slow, 800, 700, 600, 500, 400, 300. So you can see the distance matters. And the reason that the further away you get, the slower it works, is it's putting out positives and negatives that are separated. When the airflow slows down and they slow down, they bump into each other. And because they're opposite polarity, they neutralize each other. So as an example, not a true number, but let's say you have 1 million positives and 1 million negatives coming out here. That's where your fastest decay is going to be. Here, some of them have recombined, and there might be 600,000. Here, more have recombined because they've slowed down more. There might be 300,000 here, there might be 100,000. So that's why distance is important. So I think that's my half hour. Does anybody have any questions, Matt?
No questions. I think everybody was able to understand exactly what you were trying to convey, Jim.
Okay, so you know, there was a lot there. We're going to be sending you the video of it. If in closing, if I had to make one suggestion, you know, to pay attention to, is to figure out how fast your ionizer has to work, so you don't set a requirement that can't be met, or you're maybe not meeting the requirements that should be met. But testing, proper testing and proper identification of the speed you need is what's important. Do you have any questions, Tom?
Yeah, actually I do, Jim. Thank you. Great stuff. I think we can agree, and you know, both of us have been selling ESD product for many years. I think we can both agree that we're seeing a greater use of ionization today than ever before. Back 10, 15, 20 years ago, we would possibly talk about ionization as a last effort, right? Now, because of process insulators and how critical they are to the workbench, we're actually, I know, talking more about ionization up front. Would you agree with that?
Yes, yes. And for many years, you know, so I've been at this for about almost 40, and it was really the wild west, and people there weren't standards, and really it was just about making sure you had a table mat and a wrist strap. As the science has improved, the realization and identification of insulators being induced on the boards and then charge device model events occurring has become, as you indicate, much more to the forefront. Devices are smaller, more sensitive, and yes, the ionizers have become much more of a factor, and it's like I've said, it's important to as a customer to understand what's going on, the type of ionizer you're getting, and if you need help, you just need to ask.
We
Yeah,
do have
very
a question. We have a question that came in from, which is what maintenance is required for ionizers?
Good question. So generally an ionizer needs maintenance when the emitter points that the ions are produced from get dirty. They get rounded, kind of like a spark plug in a car. If a spark plug gets all dirty and gummed up, it's not going to work as well, and it will produce fewer ions. So generally, there's no law, there's no in the standard saying you have to test. Generally, it would be a good idea when you buy an ionizer to test it when you first get it, and then maybe test it after a month, and then after a second month to see actually what the difference is in performance to give you a baseline. Generally, if you're in an environment that's very clean, because what happens is that there's a very, very high voltage on the tip of that ionizer, and it will attract on the tip of the emitter point. It will attract dust particles to it, and that's what really gets it gummed up. So if you're in a clean area, then you will want to, you'll find that it will last longer than if you're in a dirty area, because there's more particulate to be attracted to it. And the cleaning process, generally, a lot of companies will do it once a quarter, whether they need it or not. They'll take them down, they'll bring them into a lab, and basically, if you take a Q-tip with IPA and just clean it, rub it, it will work much better. I've seen, particularly with AC ionizers that are older, they're blowing air, and we put the tester on it and nothing comes out. I mean, it's not decaying anything. Sometimes it's the power supply, but more often than not, it's because the ionizers haven't been maintained. So we ask the customer for a Q-tip and some IPA. We take it, we reach inside and clean a couple of emitter points, turn it on, good as new. So it's about getting a baseline for the performance of the ionizer, and then certainly on some kind of a scheduled basis, cleaning it with IPA and a Q-tip, even if it's performing well, just to prevent it from corroding.
Very good, guys. Great. Jim, Matt, thank you very much. Good
Thanks,
stuff
Tom.
as always. Yeah, good.
Thanks.
Thanks, Tom.
So we
Thanks
hope
to everybody.
you all found this this third edition very beneficial. And as I mentioned at the beginning, we're going to finish up. The clinic will be over next Wednesday. That's September 28th at 11:15 a.m. Pacific Standard Time. Greg will be back, and he's going to finish up on continuous monitors. And then just a reminder for everyone, SMT Supplies, who's a key partner for Desco for ESD products, is running a couple promotions for all those who have attended all four of the clinic events. We're going to have a 10% discount coupon for a single purchase on our website for almost all products, with a couple exceptions like bar solder. And then your name is going to be entered into a drawing to win the new Desco dual operator single wire continuous monitor. That's valued at $235. Again, take advantage of both. Please attend next Wednesday, learn about continuous monitors. Again, Jim, great to see you. Matt,
Thanks,
thank you
Tom.
for the support. Great training. We'll see everybody again next Wednesday. Thank you very much.
Thanks to everybody. Thanks, Tom.